This is Umar, and today we are going to try to study and predict the movements of crude oil prices. So, I have two objectives with this project. The first one is, like I said, to study and model movements in crude oil prices, and then the second one was to build a live updating web app to monitor developments in the crude oil market. So there's mainly four variables that I studied. For supply, I used the weekly crude oil inventory levels reported on the EIA API. For demand, we looked again towards the EIA API, which has a series on the weekly product supplied, which is how much output was sold from the refinery. Then we looked at the market, and we wanted to study whether the movements in the Dow Jones Industrial Average has an effect on the crude oil price. And then finally, I also wanted to sort of be able to look at the news. So now let's head over to the dashboard that I made. And this is an interactive charting tool that I made. It's updated every 15 minutes. You can specify the date range. You can look at a series that you want to study together. Scaled between 0 to 1, so it's easier to compare the movement. So if we hit generate, we're going to see so that's all the different lines. We see that this is daily price, that's the Dow Jones, and then these little dots are the news. So right off the bat, we can notice that there seems to be quite a relationship between the Dow Jones and the price. But let's go back to the presentation. The effect of the supply data. There seems to be some correlation, although we would expect it to be inversely related. So when the supply goes up, Economics 101, the price should go down. But then can we sort of mathematically express the effect of one on the other? We can, and it's weak. Supply doesn't seem to exert much influence, and we can say that because we use something called a Granger causality score. And the Granger causality score assigns a probability to the statement that variable A affects variable B. And the smaller it is actually a higher correlation because it's actually a p-value for a null hypothesis. But anyway, so we saw a Granger causality score here of 0.3 to 0.4, which is high. We want that to be less than 0.05 for us to be able to conclusively say that the level of supply does have some kind of causal effect on price. And this is with a 5 to 6 day delay, meaning that 5 to 6 days down from a change in the inventory level, did we notice a related change in the price? And we really didn't. The levels were too high. On the other hand, demand seems to have a strong correlation. And when we ran, and I think it's because its demand tends to be more inelastic, in the sense that something again we learned in economics is that crude oil is a commodity where people need to use the amount of fuel that they need to use. There's a set number of daily commutes and trucking routes, and there's only so much wiggle room there for reducing your consumption. We saw strong Granger causality scores. They came in under the threshold. We saw between 0.01 and 0.03. I'm sorry, that's a mistake. That should be 0.3. With a 5 to 6 day delay. So 5 to 6 days after a change in demand, we saw a change in price. What about the Dow Jones? Well, that was kind of in the middle. It was strong, but it was less than past demand. And as I mentioned, demand data was weekly, and it was for the past. So I think that one reason why this was weaker of an effect is because I think there's more noise to the Dow data, whereas the demand data is more directly related to the price, whereas the Dow may not have a direct impact or an immediate impact. But I think one reason that the price of oil seems to track with the Dow is because it serves as an indicator of potential future demand. In fact, that is the conventional sort of wisdom in the crude oil markets, is that if the Dow goes down, there's an assumption that the economy is slowing down and there will be less demand for fuel. So prices also tend to go down. We saw moderate to strong Granger scores. We saw between 0.15 to 0.03. So it did come in under the threshold, for the 7 day delay, but not so much for the early ones. But I think it's still a pretty on point. So now let's move on to our success with predictions. So what I did was I used a Ceramax model. And the way that the Ceramax model works is that you feed into it. It looks at the patterns in the past price, and it also looks at, you feed into it the other variables like the supply, demand, and market data. and then it generates a prediction. And at the time that it makes the prediction, it doesn't know what the price would be on October 13th, but it does need to know where the Dow Jones was, what the supply and demand data was for that day. So when we tested it out and we gave it everything except for the price, it drew this blue line, and that was its prediction for where the oil prices would move. And you can just see, looking at this, that it does seem to track the movements in crude oil fairly closely, especially in the shorter time horizons here of a few days. But then it starts to drift further apart as we head out further in time. So my conclusions that I drew from the model were, I think one thing that would be effective would be to sort of zoom in and work on shorter intraday intervals. And to explain what I mean by that and why I say that, let's go ahead back to the chart. When you look at the predictions charted against the price and on the web app, well, we can kind of zoom in places, and we see that there is like a bit of a lag, but it's a small lag. So the predictions seem to know that there's like a fall about to come, or if they're about to go up again. But the time frames are really small, which makes me think that if we were to sort of try to do predictions, and that makes sense because we can't predict without knowing what the Dow will be, but we don't know what the Dow will be by too much of a margin. I think this model will be most effective if we have a scenario where we get the Dow Jones changes in real time and then try to immediately sort of use that to predict where the price is going to be in the next maybe even a few hours or a few minutes. Of course, this is going to require signing up for commercial grade data APIs. I think we might want to try something different in terms of target variables. So instead of daily spot price, maybe we could try the commodities futures market or the stock price of major producers. And then I think we could also get other types of input data from commercial sources that maybe the EIA doesn't have. So as the future work that I want to do, I want to add more features to the training set. The EIA has tons and tons and tons of series. I didn't have the time to go through all of them, but I think that it would be worthwhile to explore as many of them as possible. And maybe additionally some other paid data sources like the API that I mentioned, the American Petroleum Institute. The next thing I want to do is incorporate news data into the model using LSTMs. At the moment, the model is not incorporating the effect of the news when predicting the price, because it's just building that model is just computationally very, very intensive, and I don't think that I have the computational resources at the moment to pull something like that, like a deep neural network using LSTMs. And then it also might be worthwhile to explore other news sources. You could find a source that sort of has news dealing specifically with the energy markets. I also want to incorporate Jupyter into the web app so that I can just run code right in the browser, right in the app, like do some on-the-fly analysis. So thank you. That was my presentation. My name is Omar Khan. If you have any questions, please feel free to reach out. Thank you.